Welcome to the Week 5 video from Mth120 Statistics. Today we're going to talk about bivariate data. That's what this week is actually all going to be about. So a quick example to kind of get you in this context. Let's look at some of this education data from the 2015-2016 Illinois schools. Suppose we want to compare high schools across the state. Think of some of the best high schools. You might think of like New Trier, Glenbrook North, Neuqua Valley, Barrington, Naperville, might be some of the schools that you think of. If we wanted to compare the schools and look at which ones are better than another, a variety of measures we could do. One way we could do it is just look at the percent that are college ready, based on whatever the state is using to measure college readiness. And that's in the database. If we wanted to make a graph, a common graph we could make would be like a box plot. We could look at where they fit. So if you look at those 5 schools, you can see where they fit on the box plot, and they're definitely in that upper quartile. What if we wanted to add a second measure in here though as well? We wanted to look at 2 variables, like a bivariate data. Then we would have like an X and a Y. So what if we added on that horizontal axis the percent of students who are low income in that school? So now we have 2 variables. And if we look at those 5 schools, just those 5 schools, it looks something like this. Now, you may be suspicious, like I picked those 5 schools and they look like they're in this descending order. So here is the rest of the state. Now, if you're looking at that graph, there should be an obvious trend here. I mean, clearly, the more students that are low income in a school, the less students are college ready in that school. And that's pretty astounding. I mean, when I saw that the first time, I kind of knew to expect that, but it really just like hit me. It hit me like, wow. That is profound, like really pronounced. Clearly, the more students that live in poverty, the less students are college ready. And that's not like an intelligence thing. That doesn't make any sense. The intelligence is distributed across students equally. So what's going on there? Clearly poverty is having an effect on students' ability to attend, to have good meals, to focus while they're at school. Parents might be working multiple jobs. I mean, that's just a clear trend. That's not individual students. That's just a clear trend statewide. So this is what bivariate data lets us do. It lets us look at not just one absolute measure, like let's just see which schools are the best because they have the most students college ready. Once you start looking at bivariate data, then you can look at trends. If we look at the schools that feed into District 509, that's Elgin Community College, we are really kind of right along that trend. Some schools are actually above the trend, even though they might appear on the surface like lower performing schools because they have lower college readiness rates. If you look at the trend based on their poverty rates, they might actually be overperforming. And this is what bivariate data lets us do. It lets us incorporate additional information and not just compare one specific value to compare schools, compare individuals. We can look at these trends. And what we'll do in this chapter is investigate this, like how can I investigate that trend? Can I classify which trends are stronger than others? Can I classify like whether this is actually a linear trend or not? And that's what chapter 4, bivariate data, is all about. One other quick comment here, lest you think I'm picking on Illinois. Not every state has this type of data available, but I did get it for South Carolina, Tennessee, Wisconsin. And then here's Illinois again, and you can see they're all similar trends. The more students there are with poverty in a particular school, the less students are college ready in that particular school.